This video is on integration using residues. In today's video, we are going to evaluate the integral using residues. Now, in this video, we are going to show that integral 0 to pi d theta by a plus b cos theta whole square is equal to pi into a by a square minus b square power 3 by 2. See here, first of all, we have to put as usual z is equal to e power I theta. Clear? So what is e power I theta? E power I theta is nothing but cos theta plus I sin theta. Now if I take modulus on both sides, see here mod z value is equal to mod of cos theta plus I sin theta, which is equal to mod z is equal to, this is root over cos square theta plus sin square theta, which is equal to 1. Therefore we got the region as mod z is equal to 1. So this is the circle with center 0 and radius 1. And the next thing here is we need the value of d theta. For d theta value, see here again we have z is equal to, see z is equal to e power I theta. If I make a derivative on both sides, then this will be dz is equal to e power I theta is again e power I theta and I into d theta. So I need the value of d theta. So d theta can be written as, so this is e power I theta is nothing but z I into d theta, and therefore d theta value is equal to, d theta value is equal to dz by this value is z into I. Z into I. Clear? I got the value of d theta as dz by zi. And next one, I need cos theta value. See here, in order to substitute here, I have to write cos theta. So cos theta value is always, cos theta value is equal to e power I theta plus e power minus I theta by 2. And therefore cos theta is equal to, this value is z plus this is z inverse by 2. So cos theta is equal to z plus 1 by z by 2. And therefore this can be written as cos theta is equal to, this is z square plus 1 by this value is 2z. So cos theta value is equal to z square plus 1 by 2z. And here our mod z value is equal to 1. So now we have to solve this one. So which one we have to solve? Integral 0 to pi. So this is integral 0 to pi d theta by this value is a plus b cos theta whole square. So here it is 0 to 180 degrees. So this can be otherwise written as half times of 0 to 2 pi d theta by this value is a plus b cos theta whole square. Now in order to solve this, I'll solve this because both the values are same. And now in this integral, if I take, see in this integral, if I substitute all the values here, so as d theta value I'm showing, d theta value is equal to, d theta value is equal to, this is dz by zi, and cos theta value is equal to, see this value is z square plus 1 by 2z. This is z square plus 1 by 2z. And therefore instead of solving this, I'll solve this. So I am taking this integral as half times of, this is half times of 0 to 2 pi d theta by this is a plus b cos theta whole square. So in this I'll substitute all the values. So if I substitute all the values, you see all the values are ready as, this is half times of 0 to 2 pi, and d theta value is nothing but dz by this value is zi by this is a plus b into, what is cos theta here? Cos theta is nothing but z square plus 1 by 2z. This is again whole square. Clear? And therefore this can be written as half times of 0 to 2 pi, 0 to 2 pi, this is dz by this value is zi into, if I take 2z as LCM, this will be 2az plus this value is bz square. If I multiply inside, so this is b whole square. Clear? And now in my next step, it will be 1 by half times of 0 to 2 pi. This value is dz by this is zi into, this is, if I keep it in an order, this will be bz square 2a into z plus b whole square by, so if I square, this will be 4z square 4z square, and therefore my next step will be half times of 0 to 2 pi. So if I send it to the numerator, this will be 4z square into dz by this value is z into I, this is bz square plus 2az plus b whole square. Now which one I can cancel? Z for one time, and in 2 table this goes in 2. So what remained here, this value is integral 0 to 2 pi. This value is 2z into dz by I times of this is bz square plus 2az plus b whole square. Now what is our f of z? So f of z value is nothing but integral f of z into dz. So the remaining part integral dz in between. So f of z value will be, this value is 2z by I times of this is bz square plus 2az plus b whole square. Now in order to find the poles, what we have to do? So we have to equate the denominator to 0. So if I equate the denominator to 0, this will be I times of this is bz square plus 2az plus b whole square is equal to 0. So then see, so if I send the square to other side, it will be root, and what remained here, this is bz square plus 2az plus b is equal to 0. So we have a formula here that is minus b plus or minus, so I am applying this formula that is minus b plus or minus root over b square minus 4ac by 2a. So if I use this formula, this will be minus b, this is minus 2a plus or minus root over b square minus 4 into a into c. It is again b square by again 2 into b. 2 into b. Now our pole values will be, so this value is equal to, this is minus 2a plus or minus. If I take 2 from this, so if I take 2 from this will be root over a square minus b square by 2b. And again by next step here is, if I take 2 common, then this will be minus a plus or minus root over a square minus b square by 2b if I cancel this b. So our values are minus a plus or minus. So these are our pole values which is of order 2, as there is a square in f of z, as there is a square here. So these are the poles of order 2. Let alpha and beta be the pole values. Let alpha comma beta be the two poles of order 2. Therefore, alpha is equal to, alpha value is equal to minus a by b plus or minus root over a square minus b square by b. So first one is plus, and beta value is equal to minus a by b minus root over this is a square minus b square by b. So these are the two values. See here, the region here is mod z is equal to 1. So here the region here is mod z is equal to 1, which is equal to, so this is a circle with center 0 and radius 1. So this is I and this is minus I. So for example, so here there is a case given that a is greater than 0. So here is a case that it is given that a is greater than 0, b is also greater than 0. Here is the condition I am bringing now. So a is greater than 0 and b is also greater than 0. So if it's greater than 0, so consider this as 1 and this as 1. So if you see, this is minus 1. And here if you see, if you consider this value as minus 1, a as 1 and b as 1. So this will be minus 1 and this is minus 1 and this will be minus 2. So beta value will be outside and alpha value will be inside the given circle, as this value is less than 0, as this is less than 1, and beta value is greater than 1, as they are 2 minus. So we have to add up this one and there is a subtraction here, and therefore alpha is the only interior pole. So for the interior pole we have to find out the residue for this. So for finding the residue, so first of all I am bringing alpha value. So alpha is the only interior pole. This is root over a square minus b square by b. Now we have to find the residue. For finding the residue I am modifying our f of, see here, f of z value. So what is our f of z value here? F of z value I'm showing, this is 2z by I times of bz square plus 2az plus b whole square. This value is 2z by I times of, this is bz square plus 2az plus b whole square. See, for modification I'm using, that is f of z is equal to, this is 2z by I times of, I'm bringing this b common, so b square, it will be b square, that is z square plus 2a by bz plus b by b whole square. And f of z is equal to, so f of z is equal to, this is 2z by I into b square into z square minus 2a by b into z plus 1 and whole square. So our f of z value is very clear as, so we got f of z value as, see here, we got f of z value as, this is 2z by minus ib square into z square minus, this is minus 2a by bz plus 1 whole square. See here, now what is our alpha and what is our beta? So this is our alpha and this is our beta. I am writing this as, see, this value is alpha. Alpha is equal to minus a by b plus root over a square minus b square by b, and beta here is minus a plus b minus root over a square minus b square by b. So if I consider alpha plus beta, see, this will be minus a plus b plus root over, this is a square minus b square by b minus, this is a by b minus root over, this is a square minus b square by b. If I cancel this one, so this value will be alpha plus beta is equal to minus 2a by b. Clear? So this is our alpha plus beta value. And clearly, if I multiply these two, alpha into beta, that is minus a by b plus root over a square minus b square by b into minus a by b minus root over a square minus b square by b. This is a plus b into this is a minus b, which is equal to, this is a square minus, this is a square minus b square by b whole square, which is equal to a square by b square minus, this is a square by b square by again b square. So if I take b square LCM, this will be a square minus a square plus b square. If I cancel these two, and these also get cancelled, and the alpha beta value is equal to, alpha beta value is equal to 1. So here, if you observe this one, alpha plus beta value is very clear as, this is minus 2a by b, and here alpha beta value is equal to 1. See, in our f of z value, see what is our f of z value? F of z is this one. F of z is equal to, f of z is equal to, that is 2b, so 2z by ib square into z square minus, this is 2a by bz plus 1 whole square. Clear? So this is our f of z. In place of minus 2a by b, I am writing alpha plus beta. In place of 1, alpha beta. See here, f of z is equal to, f of z is equal to, that is 2z by I into b square into, this is z square minus alpha plus beta. In place of minus 2a by b, I am writing alpha plus beta into z, and in place of 1, I am writing alpha beta plus alpha beta whole square. See, this will be f of z is equal to, this is 2z by I times of b square into, this is z square minus z alpha minus z beta plus alpha beta whole square. And f of z value is equal to, this is 2z by I into b square into, if I take z common, this will be z minus alpha. If I take minus beta common, this is again z minus alpha whole square. This is whole square, and therefore f of z is equal to, f of z is equal to, this value is 2z by I into b square. If I take alpha, z minus alpha common, this will be z minus beta whole square. Therefore our f of z value is equal to 2z by I into b square into z minus alpha whole square into z minus beta whole square. So we got our f of z value ready. So after getting f of z value ready, we have to find the residue for the interior pole alpha. So this is our f of z. So f of z is equal to, this is 2z by ib square into, this is z minus alpha whole square into z minus beta whole square. Now which one is in interior pole? So alpha is interior pole here. Alpha is inside the given region and beta is outside the region, and alpha is of on order 2. Therefore, residue of f of z. So we have to find the residue at pole z is equal to alpha. This value is nothing but 1 by, this is m minus 1 factorial into, this value is d by dz power, this is m minus 1 into, this is limit z tends to z naught, z minus z naught power m into f of z. F of z, here our m is the order value. M value is equal to 2, order is equal to 2, and z naught, the pole value, is equal to alpha. So if I substitute here, this will be residue of f of z at z is equal to alpha is nothing but 1 by 2 minus 1 factorial into, this is d by dz power, this is 2 minus 1 into limit z tends to alpha, z naught is alpha, this is z minus alpha, and the order is 2 into f of z. So what is our f of z here? This is 2z by, see here, this is 2z by I into b square into, this value is z minus alpha whole square into, this value is z minus beta whole square. So if I cancel these two and substitute in place of z as alpha, so this will be 2 minus 1 factorial is 1. So this is d by dz times of limit z tends to alpha. So this is 2z by, this value is ib square into z minus beta whole square. See here, so this can be written as limit z tends to alpha. I have to make a derivative for this for one time. So as these are constants, I am bringing it outside, that is ib square into, this is the derivative for z by z minus beta whole square. So z minus beta whole square, as 2 by ib square is a constant, as this is of the form u by v. So this is of the form u by v. What is the formula here? This is v square v u dash minus u v dash. Clear? Now I'll make a derivative here. So this is 2 by ib square into limit z tends to alpha. So this will be v square, that is z minus beta whole power 4 square. And this is v for one time. And again for u, the derivative is 1. And I'm writing u here. And the derivative for this is 2 times of z minus beta. That's it. For beta, this is 1. So if I take z minus beta outside and cancel, this will be 2 by ib square. This is limit z tends to alpha. This is z minus beta. If I take common from these two, this will be z minus beta minus, this value is 2z by z minus beta power 4. So if I cancel for one time, this will be cube. So this is 2 by ib square. So we have to write this as limit z tends to alpha. This is minus beta z minus 2z. So this will be minus z by z minus beta whole cube. So this is whole cube. In place of alpha, I am substituting. In place of alpha, I am substituting, that is limit z tends to alpha. If I take minus common, this will be beta plus z by, this is z minus beta whole cube. So if I keep alpha in place of z, so this will be 2 by iz square into minus of alpha plus beta. In place of z, I have kept alpha, and this is again alpha minus beta whole cube. So this value is nothing but residue of f of z at the interior pole z is equal to alpha. So now what is alpha and what is beta? So residue of, see here, this is residue of f of z at interior pole z is equal to alpha, we got as 2 by ib square into minus of alpha plus beta by alpha minus beta whole cube. Clear? Now what is alpha and what is beta? So here is the alpha value and here is the beta value. alpha and beta value. See, this value is alpha and this value is beta. So if I add up these two, alpha and beta, see here, this will be minus a by b plus root over a square minus b square by b minus a by 2 minus root over a square minus b square by b. So both got cancelled and alpha plus beta value is equal to minus 2a by b. So I need alpha minus beta. So what is alpha minus beta? Alpha minus beta is minus a by b plus root over. This is a square minus b square by 2 and minus of minus. This is plus a by 2. This value is again plus a square minus b square by b. So if I cancel these two, then alpha minus beta value is nothing but 2 times of root over a square minus b square by b. So this is our alpha plus beta value and this is our alpha minus beta value. So clear, this is our alpha plus beta value and this is our alpha minus beta value. Now I am going to substitute here in this. So this value will be the residue value. Now the residue of f of z at z is equal to alpha is equal to 2 by ib square into minus of alpha plus beta is nothing but minus 2a by b by, here alpha minus beta is nothing but 2 into root over a square minus b square by b whole cube. Clear? Now this will be the residue value, that is ib square. So minus 2 to minus, this is plus, this is 2a by b, and clearly, so if I send it to the numerator, this will be b cube and 2 cube is nothing but 8 and this is a square minus b square par, this value is 3 by 2. Now 2 2s are 4 and this remains and b cube got cancelled and here this will be 2 into I into this value is a square minus b square par 3 by 2. So this is nothing but the residue of f of z at z is equal to alpha. Now we have to apply, which theorem we have to apply? Residue theorem. According to our residue theorem, so according to our residue theorem, so integral f of z into dz is nothing but this is 2 pi I into sum of the residues. See here, sum of the residues at interior poles. So what is the interior pole here? So interior pole is alpha. Therefore our integral value, that is half times of 0 to 2 pi. Our question here is 0 to 2 pi. This is d theta by a plus b cos theta whole square. So d theta by a plus b cos theta whole square is equal to, this is 2 pi I times of the residue of the interior pole, that is 1 by 2i times of a square minus b square par 3 by 2. So 2i and 2i got cancelled and we got the value as half times of 0 to 2 pi d theta by, this is a plus b cos theta whole square, value is equal to pi by, this value is a square minus b square par 3 by 2. So this can be otherwise written as 0 to pi d theta by, this is a plus b cos theta whole square, value is again pi by a square minus b square par, this value is 3 by 2. So this is how we have to solve, and thank you so much for waiting, and let me explain you for one time, as this is the most important theorem. Don't feel that this is lengthy, as I've explained in a vivid manner, so this become a lengthy one. So this is the question, evaluation of integrals using residues, and in this question, see here, we have to evaluate integral 0 to pi d theta by a plus b cos theta whole square. So which is equal to pi a by a square minus b square. So every time I have taken z is equal to e power I theta and mod z is equal to 1 here. So this is the region with circle with center 0 and radius 1, and I need d theta value. For d theta, z is equal to e power I theta, and again if I make a derivative, then d theta value is this one, and again I need cos theta value. For cos theta, e power I theta minus e power minus I theta by 2. So if I substitute everything, cos theta value is ready. So instead of solving this one 0 to pi, so it is 0 to 180 degrees, and half times of 0 to 360 degrees is also same, and I have taken this integral for my convenience. See here. So in this integral, so I have taken this, chosen this integral, and in this integral, if I substitute d theta value as this one and cos theta value as z square plus 1 by 2z whole square, and if I take 2z as LCM, and if I solve this one, so f of z value is this one. With f of z value, if I equate the denominator to 0, if I equate the denominator to 0, I'll be getting the pole values. So here are the two pole values, that alpha and beta are the two poles with order 2. So here this is alpha and this is beta value. See, if you observe this one, mod z value is equal to 1. So this is a circle with center 0 and radius 1. So in this, if I take a is equal to 1 and b is equal to 1, so this is minus 1 plus something. So here there is a subtraction, and alpha value will be within the circle, that is within the circle, that is mod z is equal to 1, as alpha value is less than 1. And beta value, if you take 1 1, so this will be 1 1, this will be minus 2, and it will be outside the circle, and therefore alpha is the only interior pole, and I have taken alpha, and again I have taken f of z value, and see here, I have taken b common from this. So b square, I have taken b square common, and I have written minus 2a by b plus 1 whole square. So see here, alpha value is very clear as this one, and beta value is this one. If I add up these two, so this is the value. If I multiply these two, so this is sum of the roots and this is product of the roots. So in place of minus 2a by b, I wrote alpha plus beta. In place of 1, I wrote alpha beta, and after solving, so I got f of z value is very clear as this one. So alpha is a pole with order 2. So as this is an interior pole, I have to make find the residue for this. Z is equal to alpha. So this is the formula for this. Z naught is equal to, so what is Z naught here? The pole value alpha, and m is the order of the pole, that is 2. M is equal to 2 here, m is equal to 2 is the order of the pole, and here Z naught pole value is equal to alpha. So if I substitute, and if I make a derivative for one time and substitute z is equal to alpha and this one, so what is alpha plus beta and alpha minus beta? So I have to both the values alpha and beta. So this is alpha plus beta and this is alpha minus beta. If I substitute here alpha plus beta and alpha minus beta value, I got this one. Now this is the residue value at the interior pole, z is equal to alpha. Now I have to apply residue theorem. So what does this residue theorem states? Integral f of z dz is nothing but 2 pi I times of the sum of the residues at the interior poles. So the interior pole is nothing but the alpha. So this is integral f of z is nothing but this one. This is 2 pi I times of the interior pole value is this one. After cancelling, we got this value. So this can be otherwise written as this. And this is how we have to solve. Thank you so much for watching and staying till the end. Don't feel that this video is very lengthy, because I have given a clarity for each and everything vividly, and so that you can understand better. And therefore, if you understand what you have to do, please pass it on to your friends. Practice well. This is the most important question, and it will be very helpful for your preparation. Thank you so much. Go through the playlist once. So many videos are uploaded for your preparation, and please pass it on. Thank you so much.